Now all you just need to do is plug your data, and that's all. You don't know what it's actually talking about, but until you start the process, then you know what it means. I really appreciate that. Thank you very much. So today, I'm going to be talking about GIS. I'm not talking about too much development, but I'm talking about GIS. And just like when Mr. Toko was on stage, he was talking about the trend of AI in 2025. And then we had drone 2024, 2022, and all of that. So we'll be looking at how we fuse the geography, AI, and then drone. So let's begin. For smarter mapping, the next slide, please. All right, so we are in an era where there's a rapid technological innovation, and the fusion of Geo-AI and drone technology is actually reshaping the future of mapping. And we all agree that the traditional method has been very, very tedious. It's very, very tedious, part of which I was just explaining some minutes ago, converting your LSD and all of that. And also, trying to get your data and, analyzing that data. It's very, very time consuming. But now we have intelligent and automated systems that are capable of actually analyzing large landscape with very good accuracy. With very, very good accuracy. And drones provide, agile, real-time access to even the most small. It's not small. But with your drone technology now, they are just going to spend some days, maybe 5 days on site because of the cities you can establish. But after that, it's smooth sailing. And then you get your data, we just bring it to the lab and then we process it. Very easy. Okay, so Geo-AI transforms real area data into meaningful insights through advanced algorithms, pattern recognition, and predictive analytics. Now, this enables smarter, faster, and more dynamic mapping solutions that support everything from urban planning to disaster response to environmental monitoring and infrastructural development. All right, next slide, please. So we'll be looking at what is AI, artificial intelligence. And it's a multidisciplinary field. Okay, it is a multidisciplinary field of computer science devoted to So it's devoted to creating systems capable of transforming tasks and that typically require human intelligence, such as perception, learning, reasoning, problem solving, language understanding, and decision making. It encompasses what? A broad set of computational techniques, including machine learning, which Mr. Messi talked about. So machine learning, deep learning. So the first layer is machine learning. The other layer is deep learning. Okay? And then we have natural language processing, computer vision, knowledge presentation, robotics, and expert systems. So artificial intelligence is a combination of machine learning, deep learning, and all these other computational techniques. Before, when we used to do land cover classification, we used the Microsoft law. Okay? What is the pattern over time? As organization grew over time. All these are what GIS helps us to understand. And so many more. So many more. And GIS will cut across a lot of fields, not just restricted to geography now. It goes to economics, finance, want to cite a new bank, for example, and get the data of all the customers, code their addresses, and so where are all the customers coming from? you see that they are traveling a long distance to get to banking facilities, then you can suggest the bank should cite one close to their customers for easy access. So you don't just randomly pick the sites to now, cite your bank. There are other criteria you look into, and then you cite your bank there as well. So a lot of agriculture in agriculture as well. You want to go into agriculture, you want to plant a certain crop. You get your data, when you get your data, you do your analysis, all the multi-criteria decision analysis, and you look for the suitable place to plant your crops. Are we together? So these are things that GIS helps us to understand. Just name it a few. Now, a brief history of GIS. Brief history of GIS. Who knows the history of GIS? Where it actually started? Samus is there on that. You remember John Stowe, the man that discovered the source of cholera outbreak in England in the 1850s or so. Okay, he's the one that, before even GIS became a thing, he was able to trace the source of the cholera outbreak. This is not microscope or anything. He actually traced it going from neighborhood to neighborhood. He got to the source, and he did that using map. And that's how GIS was now better. In the 1960s, the beginning of modern GIS with the Canada Geographic Institute system, led by Roger Tomlinson, the first computerized system for storing, analyzing, and mapping vast geographic data. So it started with Canada Geographic Information System. Then we moved to the 1970s where S3 now came in. And, Esra has become one of the brands that, if you are talking GIS today, there is no way you cannot mention them. Yes, GIS is right back, but, Esra stand back. So whenever we're talking GIS, but it started in the 1970s to 1980s, and then they grew from there. Then we had the desktop GIS from the 1990s, where GIS became more accessible with desktop tools like ArcView, integration of GPS and remote sensing, strengthening spatial analysis, spreading GIS into fields like planning, environment, and transportation. Then in the early 2000s, where internet and open data broke out, there is the rise of web-transformed GIS, online mapping platforms like your Google Maps 2005, and open data efforts like the OpenStreetMap, which made GIS data widely available for all of us. You can testify to OpenStreetMap. There is nobody that's not using OpenStreetMap now, because you can easily get your vector data from there, for roads, your points of interest, and the rest of them. Okay. Then 2010 to present, we now have the cloud. So it makes it smart. You don't need to waste too much time trying to analyze. It can tell you to actually give you the statistics for a particular location, and it will do that and visualize it for you. Very, very interesting. So other AI platforms with geospatial extensions, we have the Google Earth engine. For me, Google Earth engine has been a lifesaver for me. I don't need to start downloading enormous satellite data that will be like gigs. And then start analyzing them for sec and all of that. But with Google Earth engine, I just write the code. It uses JavaScript. Okay. I think there's also the Python version if you are into Python, but it uses JavaScript as its code base. And easily you can just perform your machine learning for land cover classification, and we use it widely for climate, land cover, and environmental modeling. And we have Google Map platforms and AI APIs. just like Mr. Messi has mentioned earlier. Then we have the Microsoft Azure Maps and Azure AI. Then we have Pix4D, which is for your drone mapping, and it also has the AI-based feature extraction for drone as well, widely used for agricultural construction and surveying. Okay, let's play the video. So I want to show us an example of what we did with Google Earth Engine. So we have a lot of work here. So this is the land use and cover for Nigeria, where we picked the training samples. We picked the training samples, as you can see here. We have water, vegetation, rangeland, hilltop, and rest for Nigeria. Once you pick your training samples, then you can see here we have the codes, the functions, and everything right there. So when we click run, you will just see that the image will be classified. So these are the codes. It's very lengthy, yes, very lengthy. So you cannot a coder now, because I know. But the essence of this is to create a platform where we can easily just compare between two states or within states, you know, what has happened over time, and look at the pattern that has occurred over time. Yes, so we're running it now. So as you can see, we have the left map controls and we have the right map control. We can select the year on the left and select the year on the right as well. So we're going for 2020 and then 2022. You can select the state as well. You can select the state as well. So we're comparing between 2 years. And what we do is automatically calculate the statistics and give us the results. So you see, automatically gives you the results. So this is very beneficial. You can see the slider here to look at the comparison between the two. So we made this an app as well where you can access it. If you're a researcher, you're interested in comparing between years, what has happened over the years. So okay, we're going to Lagos now. So over the years you look at, so what we did is from 2018 or 2014 to 2024. 2014 to 2024. So this is for Lagos, and you can see the statistics on the right and on the left as well. Yeah, I'm running on this left. Alright, so let's go to the next one. Okay, please play the next one. So this is for the project I was talking about. So we have the drone imagery on the left, and then I've picked my training samples. So I have the drone imagery on the left. This is for JAWS. And then we have the machine learning one on the middle, which is your random forest classifier. And then this is the deep learning that we use as well, the model we use as well. So you can see that we have much better accuracy with the deep learning compared to the random forest. You can see we have these yellow patches for this water body, but for the deep learning, those patches are no longer there. So it gives us a better result. So what we did was pick the training samples, train the model, and then I personally took it to Visual Studio Code to be able to now run my deep learning, because I discovered that GIS Expert was slow, so I had to switch to the other part, the coding part, and it was way faster and did that processing for me. So you can see this is within the GIS environment to train the deep learning model to create the model for you and then give you your prediction. Can you forward it? Alright. So in conclusion, GIS and AI synergy together they create a powerful system for smarter mapping and decision making. Just like that previous video, that's the model I was talking about, that I can use that model for any project within JAWS. We do any project in JAWS, I just need to bring in the model and to give me my image classification very fast. Okay? And then the core rules, GIS provides the location data, AI analyzes the pattern, automates the tasks, and predicts changes for us. And then we have transformative impact, turning complex spatial data into fast, accurate insight for better planning, monitoring, and problem solving across